page 24, question number 2, continuing on with unknown angle problems, we are told in this question that we have two parallel lines. So we have that line segment AB is parallel to line segment CD. That is given to us. And we know that there's a lot of things we can do with our parallel lines. One of the things that you want to remember is that it is oftentimes marked in your picture, so that if you don't see it listed as a given, it's going to have those little arrows on it. And we are looking for things like corresponding angles or alternate interior angles or consecutive interior angles in order to finish working on this question. So one of the things that I see is that I have a bent transversal, which is really two transversals that meet at this point that's over here. And we've talked about how when that happens, we want to draw something called an auxiliary line. So our auxiliary line here is going to be the line that we draw in that passes right through that point. And when that happens, and we draw that auxiliary line, which is of course dotted, we draw that in such a way that it's going to be parallel to the other two lines that we have in there. So when we're doing our justification, we probably want to go into our proof and identify that we have drawn that auxiliary line in such a way that it's parallel to the other two. So I'm going to list in here that I'm drawing EF, it's parallel to AB and parallel to CD. And I'm going to say that I drew an auxiliary line that's parallel to the other parallel lines. Because now that I have all of those parallel, I am able to go through and do things with those angles that are going to be formed. So when I'm looking at angle Z, remember we talked about how angle Z is split into two parts. There's no guarantee that the two parts that are being split by that auxiliary line will be equal. And I'm just going to make life a little easier and call one of them angle A and one of them angle B. No guarantee that angles A and B are equal to each other. But when I have parallel lines, one of the things that I do notice is if I'm looking at my top and middle parallel lines, that this transversal that goes along the top here does identify angle X and angle A as corresponding angles. So because they're formed by those parallel lines, I can say that angle X is congruent to angle A because parallel lines make corresponding angles congruent. And then when I'm taking a look at angle B, I can see that if I focus on the middle parallel line and the bottom one, that I do have this transversal that passes between the two of them. And what I end up noticing is that angle Y and angle B are also congruent to each other because they are corresponding angles as well. So I'm going to write that statement right in the same exact reason. And now that we have angles A and B identified as being congruent to angles X and Y respectively, one of the things that I can say in my proof is that I notice that angle Z is equal to angle A plus angle B added up. Remember we talked about how we're splitting angle B into two parts, not necessarily equal. So that means that angle Z is equal to both of those two parts. So my reason for this is that the whole angle is equal to the sum of its parts. But remember, if we look back at our proof line, we didn't want to know that angle Z was equal to angle A plus angle B. We wanted to know what it says that it's equal to angle X plus angle Y. So if I take line 4 and I do a substitution, I can say that angle Z is equal to not necessarily angle A, but because this tells me that angle A is equal to angle X, I can substitute X in for A plus angle B, which I know is really equal to angle Y, and I am able to go through into that substitution and actually finish my proof